Hello students, and I would like to welcome all of you for this class of Misostudy. And as it is clear from this first slide of this PowerPoint presentation that in today's video shoot we are going to discuss a very important aspect of your preparation, that is some good questions from wave optics. It is a very important chapter. Fine. So, class 12th very important chapter, and that too selective questions of main pattern, that is joint entrance exam main pattern questions. Now, here in Misostudy we do not like to work towards quantity, we love for the quality. Fine, our love is, our dedication is for quality. So, whatever we are going to discuss over here, it is not like that mere 10 questions, 15 questions, 5 questions, no. Here with each and every problem we would like to share how exactly you can learn, to solve the questions those you are going to get in your competitive exams. Fine. So, with this approach I would like to start this discussion over here, and what I will do, one by one I will provide you questions and I will not rush. Fine, I will explain question properly, then I will provide you the solution. Here I will do a minor change, that is all these detailed solutions are going to be the part of your package. Fine. So, rather than wasting time of each and every step, I will try to explain you the basic approach. Fine. If you are interested for the detailed solution, it is available in your ebook. Fine. So, with this note, kindly be with me for the coming 35-40 minutes. We will try to discuss some good questions, and that too for JEE Mains pattern. So, students, here it is a first question. Now, do not consider it as a big question. Problem is, this is not a big question, due to some compact space it is visible like this. Fine. First we will try to understand what exactly the question is. So, here a beam of unpolarized light passes through a tourmaline crystal. It is a device, you can say a specific type of crystal that will help you to produce some polarization. So, initially you have unpolarized light and it is passing through tourmaline crystal C1. C1 means possibilities, there are various crystals. So, first crystal is C1, and then it passes through another tourmaline crystal C2, fine, which is oriented such that its principal plane is parallel to that of C2, fine. The intensity of emergent light is I0. Now, C2 is rotated by 60 degree about the ray. The emergent ray will have an intensity how much? Fine. So, what we will try? We will first try to understand the problem. Okay. What exactly the meaning of unpolarized light? Unpolarized light means, you know, light waves has two vectors, electric vector, that is E, fine, and magnetic vector, that is B. Out of these two vectors, only electric vector has the tendency to oscillate, to vibrate in all possible directions, fine. So, unpolarized light means the electric vector is oscillating in this fashion, that is all possible directions. Okay. When we are forcing this light to pass through this tourmaline crystal, what will happen? It will allow only passes of one type of these electric vectors, and remaining are going to be shun out. Now, you have two tourmaline crystals, or you can say polarizer, fine. Now, what exactly the role they are going to play? First we will try to understand that. So, let me allow to erase out this thing, and I would like to show you the role played by these tourmaline crystals, fine. So, let us say this is one tourmaline crystal or filter, okay. that is C1, C1, fine, it is C1. Now, the possibility is like this, the axis is oriented, okay, this fashion. So, another is also like this, fine, this is C2, this is C2, fine. What are the possibilities? Pick these two crystals, place them on each other, that is parallel, or another is try to rotate one crystal with another. Say for example, with the help of duster, I would like to show you. Let us say these are two tourmaline crystals, fine, and vertically downward there is passes. Now, what you can do? You can place it like this, so you can get the light that is coming from this side, from my face side, but I now am rotating it, fine. So, what will happen? Axis is changing. So, in second statement, rotated by 60 degree means one crystal rotated with respect to first one. So, it is like that initially like this, then it is rotated like this. So, we have to examine these two conditions. You know the formula I is equal to I naught cos square theta type of result. Obviously, we will use that result, fine. So, now I would like to start how you are going to attempt this problem. I hope the problem is clear to all of you, okay. Let us start this solution. I will use the available space over here, so that you can correlate the explanation at this point with the particular question, fine. So, in this I can say intensity of light that is coming out from first crystal. So, ultimately we have to find out that, fine. So, intensity of light coming out, intensity of light coming out from intensity of light coming out from C2 is equal to, let us say, I naught, fine. It is given in the question also, and we are trying to mention it in this fashion. So, intensity of light coming out from C2 is I naught by, I think I should use a different color chalk for this next statement, that is by rotating 60 degree. It is given now C2 is rotated by 60 degree. So, by rotating either you can say pi by 3 or 60 degree as you wish. So, pi by 3 or 60 degree, fine. So, what you will get? You will have to use the formula I is equal to I naught cos square theta. So, let me allow to write down that formula, that is I is equal to I naught cos square theta. You know the value of theta, it is pi by 3 or 60 degrees. So, put the values over here. So, cos 60 is 1 by 2, sin 60 is root 3 by 2, fine. So, after using theta value, if now directly I am saying I is equal to I naught by 4, you will say yes, it is simple and correct. So, now student, this is the approach. What exactly mentioned in the question, that I explained you, and C is your correct answer by this method. So, you can say the question is anyway not difficult. That is why in the starting I mentioned this is not a big question, do not get afraid by this question, fine, a simple approach and a very basic formula applied. So, with this I think now it is sufficient for your understanding. So, let us move ahead for the another problem, fine. And obviously in the same fashion with this second problem also I will try to explain an important aspect or a concept. Fine. One by one in this fashion I will keep on moving with this hope that you are taking proper interest in the explanation. Now, this is your second question. What will be the angle of diffraction for first secondary maxima due to diffraction at a single slit of width d mm? For the time being, no need to recall the number, using light of wavelength lambda. Now, what exactly the question is? Students, we are discussing chapter wave optics, and in your wave optics chapter there are basically two basic main topics from where you are supposed to get maximum number of questions. Fine, apart from polarization, Huygens concept and all these things. One is your YDSE, Young's double slit experiment, and second is diffraction, concept of diffraction. So, you can say interference and diffraction are two main themes of this chapter. Fine. So, very first thing, moment you read these type of questions, you have to find out what exactly you are supposed to find out in this question and from which subtopic this question is. So, as it is clear, this question is from the concept of diffraction. So, first thing is required the formula. Fine. And if you are regularly watching our videos, regular theory videos, you can find out that very properly in a simple manner. I always explain these type of important concepts. So, if you are regular with the videos, obviously you will find these type of questions interesting and easy. Fine. So, now the question is in front of you and you can say only formula is required. As such, no concept over here. If the idea or the concept of diffraction is clear, this question is simply you have to use a specific formula and then you will get the answer. So, let me allow to mention the formula. What is? For secondary maxima, fine, for secondary maxima. Now, why I am mentioning these statements? So that if you are regularly watching theory videos and then if you are reading the problem, then in totality you can understand the aspect of the questions. Fine. A sin theta. In different books this A may be mentioned as D also. Don't get confused. The diagram during the discussion of the topic I explained, you can define that particular diagram. So, A sin theta is equal to 2n plus 1 lambda by 2. Now, in interference and diffraction, during the discussion of both these topics, we specifically discussed two situations for both concepts: minima, maxima, minima, maxima. For interference, maxima, minima equally distributed. For diffraction, it is different. There is a central maxima and to both sides of that central maxima, sudden decrement in the intensity of the minima. So, A sin theta or D sin theta is equal to 2n plus 1 into lambda by 2. From here, what we can say that sin theta is equal to 2n plus 1 into lambda by 2a. Fine. No, nothing I did. I simply transferred it. Fine. From here, something important in this particular formula. Fine. So, that is why I am writing again and again, so that you can take a look of this formula once, twice, thrice. So, ultimately it is going to be stored in your mind. Okay. So, sin theta is equal to this 2n plus 1, where n has 0, 1, 2, 3, 4, 5, 6, so on numbers. Fine. Now, finding the values, you can say I am going to write down in a simple fashion, that is by putting the values. That's why in the starting of this problem I said, if the concept is clear and you know the formula, as such in this question nothing is difficult. But if you don't know the formula, everything is almost difficult. So by putting the values in, let's say, equation number 1 in 1 and solving, let me allow to use this space, that is theta is nearly, obviously students, angle if you are finding, so exactly you cannot say like that it is exact value, so that's why I am saying nearly equal to. Fine. So theta is nearly equal to 0.0015 radian. Fine. 0.0015 radian. This is your answer, and as per this A is the correct answer, 0.0015 radian. Let me quickly summarize it. In your wave optics chapter, YDSE diffraction, that is interference diffraction, important. Please practice properly formulae and condition for maxima and minima. And when you are doing the practice, my suggestion is use some rough papers, fine, and draw the diagrams once or twice so that you can visualize the diagrams just by closing your eyes. Fine. Okay, this is one slide, this is one slit, and then there are two slits, and then light rays are going to the screen and patterns are visible, something like that. YDSE, Young's double slit experiment. So this is the best approach for this chapter. Fine. Because if you will not do like this, moment you will solve one question from diffraction, then in next question you will definitely find things are not very easy for you to understand. So in this chapter things are really interesting, but they demand some sort of dedication from your side. Okay. So let's change this duster and be ready for the next problem. That is this third question. First we will try to understand. Yellow light is used in a single slit diffraction experiment. My suggestion to all of you is stop your video here. Why? Because similar type of statement or question I just discussed, question number 2. Now if you stop your video, what will happen? You can read it, think it, try it, after that run the video so that you can match your approach. Fine. So yellow light is used in a single slit diffraction experiment with a slit of width d. Numbers are not so important. If yellow light is replaced by X-rays, what exactly replaced? Not light is replaced, but indirectly wavelength has been changed. Yellow light means between 4000 to 7000 angstrom, and X-rays huge amount of energy, so wavelength is very small. So you can say the value of wavelength decreasing sharply. Fine. Then the observed pattern will reveal what? It means, listen, forget this question, listen statement. If in a diffraction pattern experiment we change the wavelength, what will happen with the pattern? If we are increasing the wavelength, if we are decreasing the wavelength, sharp decrease, sharp increase, it means you should know the variation of wavelength with the pattern. Simple. In nutshell, the idea of this question is only this much. Okay. So let me write down a single line over here. That is impact of lambda variation on pattern. Simple. This is the main idea of this question, impact of lambda variation on pattern. Fine. So now as usual, which parameter we are going to use to understand this pattern variation. So ultimately we need some mathematical formula. Fine. So here angular width WIDTH, angular width of central maxima, because in diffraction pattern, as I told you, central maxima is important. Fine. So angular width of central maxima, because if we can find out central maxima, then easily we can predict about the change in the pattern. Fine. So it is going to be 2 theta is equal to, that is what, angular width of central maxima 2 lambda d by a. Sometimes in few books, in few questions, they may use small d, because here in questions I mentioned like that, so that's why I am using a. There is no hard fast rule for that. In general, capital D is the spacing of the screen. Fine. So that's why I am using it. Now for yellow light, lambda is roughly 6000 angstrom. Fine. Let me allow to write down that. For yellow light, I am writing with the blue color chalk. For yellow light, lambda is equal to angstrom, or 6 into 10 to the power minus 7 meter. Fine. So for yellow light, lambda is this much, and for X-rays, lambda is 1 into 10 to the power minus 10 meter. Fine. That is 1 angstrom. Imagine the situation. The difference is how much. So for X-rays, lambda is 1 of the order of 1 angstrom. So I think I should mention that line. That is important. That is important. Yes. So let's mention it over here. For X-rays, lambda is the order of 1 angstrom. Very, very minute, not difference but value. 6000 angstrom, 1 angstrom. Fine. So this is nothing but 1 into 10 to the power minus 10 meter. So now what we can say, that the difference is very large over here. Fine. So what exactly the pattern is going to be? More number of fringes, less number of fringes, no diffraction pattern. What will happen? So from here you can easily find out, if you reduce the lambda, theta is reduced, because 2 basically meaningless, and as such no change in capital D and small a. So you can say directly theta is directly proportional to lambda. So reduction in lambda, it is also going to be narrow. Fine. So if it is also going to be narrow, then the central maxima is narrower. Fine. More number of fringes. Who is interested for fringes? In diffraction pattern, it is not like that. Less number of fringes, again something associated with interference. No diffraction pattern, no, it is not like that, because lambda is existing. Fine. So ultimately what is important? The central maximum is narrower, reason theta is directly proportional to the wavelength. Reduction in wavelength, impact of lambda variation. Fine. So this is the simple approach of solving these problems. Okay. Let's get ready for the next problem. And for all of you, I am not explaining these problems keeping in mind some different students. I am explaining for all type of students. Some quick explanation, some step by step simple explanation, so that everyone can be associated with these type of problems. Fine. Let's move for the next question. And as I mentioned, long solutions are part of your this e-book, but over here we are just discussing approach. Obviously, we are providing the solutions also. In a double slit pattern, somewhere the idea should come in your mind, is it like that it is associated with interference pattern? Wait, let us analyze more. In a double slit pattern, when wavelength is this much, it is yellow color type of thing, the first order and 10th order maxima fall at 12.50 mm and this value, okay, from a particular reference point. So, now up to some extent things are clear, somewhere we are trying to find out interference pattern. If lambda is changed to 5500 angstrom, again change in wavelength, but not sharp change, a very minute change of just 500 angstrom. Other arrangements remaining same, means slit spacing, screen spacing, everything same. Position of 10th order maxima will be how much? Fine. So, first maxima, then minima, then maxima, then minima, so on so forth. Fine. So, you have to find out 10th order maxima if wavelength is slightly decreased. So, I hope the problem is clear. Again, I would like to write down simply one sentence, and that is impact of lambda, sorry, impact of lambda variation on pattern. Fine. Impact of lambda variation on pattern. Basic idea is this. So, let us try to find out what exactly the solution of this problem. Few sentences I am writing. I hope you will find this explanation easy, and that explanation is between first order between first order and 10th order, between first order and 10th order, there are between first order and 10th order there are 9 fringes. Yes, there are 9 fringes of fringe pattern. Okay. So, 9 beta is equal to 14.75. 14.75, and what is the value given as? It is 12.50 minus 12.50. So, 9 beta is equal to 14.75 minus 12.50. So, what it will give you? It will give you 9 beta is equal to 2.25 mm. It means beta is equal to 0.25 mm. Yes, fine. So, it is going to be 0.25 mm. This is one statement, and I hope as such this first explanation is clear to all of you. Okay. Now, from here, because I do not want to move far away from the question, so what I will do, I will erase out this portion, then I will explain you next aspect. Okay. I may use other space available with the board, but then what will happen, I will move lot of away from the question, that I do not want. Fine. So, if first part is clear, then let me allow to move on to the second part, that is over here. Basically, we will try to find out the impact of lambda variation on the fringe width. Fine. So, when, and whatever I am thinking in simple terms, I am giving the language only to that thinking. Fine. When lambda is changed, then new fringe width, when lambda is changed, then new fringe width, fine. In this situation, the new fringe width, let us say beta prime is equal to upon 6000. Fine, because new is 5500, it is given, and initial old one is 6000 angstrom into original fringe width beta. And what is the value of beta? Just here I mentioned it was 0.25 mm. Okay, it means beta prime is equal to 11 by 12. 11 by 12, 5 and 5, 5, yes, 11 by 12 into 0.25 mm. So, obviously, it is going to reduce slightly. When we will solve it, it will give us beta prime is equal to 0.23 mm. Fine. So, this is the new fringe width when you are changing the wavelength. This is again very important, the way I mentioned how lambda change will produce some changes in the fringe width. Now, I will have to explain final step of this particular question. So, what exactly the final step? Listen carefully, because initially I do not want to erase out for the few seconds. Listen, after finding out this new fringe width, that is beta prime, what we will say that position of central maxima remains same. If you are changing lambda, you can change, but position of central maxima will remain unaffected, will remain unchanged. Okay. So, this statement is also very important, that is position of central maxima will remain unchanged. Fine. Unchanged. Position of central maxima will remain unchanged. So, what you can say, 12.50 minus 0.25, 12.50 mm given minus 0.25 mm. So, ultimately you will get 12.25 mm. Fine. Now, new position of 10th order, new position of 10th order because that is something we are supposed to find out. New position of 10th order is y is equal to this value of 12.25 plus 10 beta prime, that is 12.25 plus 10 beta prime. And what is the value of beta prime we calculated? That was 0.23. So, that value is 0.23. Ultimately, when you multiply it and add it, you will get it as 14.55 mm. Actually, because I was not decided, I decided not to move away from the problem. That's why I used 3 steps to explain this. Otherwise, the problem was just for 3 or 4 total steps required. Fine. So this is your answer, and this way you can say B is the correct option. Okay. Obviously, now we have to move for the next problem of this particular set. Fine. And I hope the simplest possible approach with the help of which I am trying to explain the problems, almost all of you will find yourself in a comfortable position. Fine. Here is the 5th question. Light is incident normally on a diffraction grating. Moment you are getting these type of sentences, you should know what is the meaning of this, and for that you have to keep on revising your basics. Through which first order diffraction is seen at 34 degree. The second order diffraction will be seen at what angle? Fine. So as such, nothing is difficult in this question, a formula based problem, simple. And what is that formula based problem? That is using the expression A plus B sin theta is equal to n lambda, equation number 1. This is the general result that we are supposed to use. Sin theta 2 upon sin theta 1 is equal to 2. It means sin theta 2 is equal to 2 sin theta 1. Fine. So theta 1 is given 34 degrees. So sin theta 2 is equal to 2 into sin 34 degrees. In general, these type of angle values in general provided in the starting of the question paper. Fine. So you need now to remember these values. So or even at the bottom of the question it may be given. So sin theta is equal to 2 sin 34, and then sin 34 roughly you can say 0.55, 0.56 type of thing. So multiply 0.56 with 2, you will get sin theta 2 is greater than 1, which is not possible. Fine. So ultimately what you can say that this sin theta 2 is greater than 1, which is not possible. So you have to subtract that value from your 90 degree angle, and then you can find the correct answer, which is going to be correct answer is D. Fine. So this is a checking condition. Okay. And then you can easily find out the solution of this problem using this formula. Now what I would like to mention over here, because these were slightly long problems, fine. So I would like to suggest all of you just take a break over here. At some point of time again we'll come back with some more good collections of the problems. Okay. So till then keep revising. If anything you find difficult over here or in any problem or in any video shoot in theory, please feel free to share with us. Till then, take care. Thanks a lot for watching this video.